I've been working in PayEx for a couple of years as a business architect, focusing on APIs. And before that, I worked in a company called OKB that was bought by PayEx a couple of years ago. There I was the CTO and also had a focus as a lead developer and lead architect. And before that, I've been working in consultancy and Norwegian Broadcasting Corporation, mostly involved in interface development, CSS, stuff like that, and more and more focusing on API development the last few years. So that's what I've really loved doing now, is being a web architect and doing API development. So today I'm going to talk a bit about REST and Hypermedia. A little bit about myself. I'm Asbjorn Ulsberg and I'm a business architect here at PayEx. I focus mainly on web, API and interfaces. That's kind of my core competency. Before we start talking about REST, let's do a bit of history. PayEx has spent the last few months building new APIs for payments. Those APIs are based on REST. They are more lightweight, more flexible and more scalable than the previous APIs we built, which was based on SOAP. But what is REST and what is the underlying principles of REST? To answer that, we need to go a bit back in time. We actually need to go back to the 1930s, where this man, Luis Jorge Borges, he started in the 30s thinking about hypertext. And in 1941 he wrote a book called The Garden of Forking Paths that is about a manuscript which has pages referencing each other in different ways. So depending on which page you start from, you end up somewhere else. And this forking of the storyline is the first written down we have of hypertext. And in the same way as the Garden of Forking Paths can be found in modern RPG-style games like BioShock Infinite and Fallout 3, where the story forks in a different direction depending on which option you choose. And then in 1963, Ted Nelson coined the terms hypertext and hypermedia. In 1968, Douglas Engelbart held a presentation of the online system, which has a page on Wikipedia called The Mother of All Demos. It was a fantastic demo of the online system, and it had in 1968 a mouse pointer, hypertext editing, word processing, email and a windowing environment. And this was before most of you probably were born. So that was pretty amazing. Many of Engelbart's team members went ahead and founded the Palo Alto Research Center, known to most people perhaps as Xerox PARC. And from Xerox PARC, a lot of ideas came forth that had large importance on this company, Apple. And within this company worked a man called Bill Atkinson. And in 1987, he created the application called HyperCard. And it too was rather revolutionary. It was a successor to a lot of things we take for granted today, such as Xcode, an integrated development environment, Visual Studio, AppleScript, Java. It had just-in-time compilation. It had an interface builder before there was interface builder and before there were Visual Basic. It was Flash because you could do animation and you could click on objects to set properties and timing and animation properties. And it was FileMaker. Before FileMaker existed, it had a built-in debugger and fix and continue before any other program. And here are some examples of how a HyperCard program looked like. So each card can reference another card, and depending on how you click and follow the hypertext and hypermedia within each card, you end up in a different place. And then on a computer created by the man who founded Apple, Tim Berners-Lee created the World Wide Web in 1989. It went on to become what we know now as HTTP and HTML. And the co-writer of the HTTP specification, this man, Roy Fielding, wrote a doctorate dissertation in the year 2000. And within that dissertation, he coined the term REST. So, what is REST then? Well, it's difficult to answer, especially in just 20 minutes. The dissertation has 162 pages, so we can't really go through all of them now. What we can go through is a lot of misconceptions about REST. And one of them is that REST is CRUD. And that's wrong, because post does not mean create. It means do something with the resource you're posting to. And to underscore the versatility of post, the entire SOAP protocol is tunneled over the post method when SOAP is used over HTTP. And there's nothing wrong with that, but that does not make SOAP RESTful, and you'll understand why shortly. So we don't really have a method for create. Post can mean create, but it can also mean a lot of other things. It's up to you. Get means retrieve or read. Yeah, that's a good map to CRUD. But put does not mean update. It means replace. So with the entirety of the request, you replace the entirety of the response or of the resource. And then you have patch, which also does not mean update. It applies a diff to the resource given the current client state. And lastly, you have delete and a few other methods. My point here is that if you think about HTTP and the methods used there as CRUD, you lose out on a lot of opportunity for how you can design your API. It's much more flexible. You have to think about this differently than you would if you created a domain model with, or a repository with create, read, update and delete methods. The next misconception I would like to point out is about URIs. Yes, they are very important in REST and HTTP. But who here can tell me which of these URIs are most RESTful? Does anyone have an idea? Second to the bottom. Any other? I'm sorry to say, none. Or all of them. We have no idea. There's not enough context to decipher whether these are RESTful or not, because REST is not about URIs in itself. Without knowing what the request and the response of these URIs looks like, what method to use on them and so on, we can't tell if they're RESTful. And also, how the URI looks like does not matter in a truly RESTful API, because the URI is supposed to be discovered through Hypermedia. So whether the bottommost URI is better or worse, it doesn't really matter. It's just an opaque string, a unique identifier for a resource. Now, that does not mean you should not invest time in designing your resource or your URIs, because URIs are important to humans. So knowing what the resource is and what it means is important to us. But to the machines using the APIs, it shouldn't matter. And that's why the structure of the URI is something the client should not know anything about. So if this is what your API documentation looks like, you don't really have a RESTful API. You have what Stefan Tilkov calls a URI API. You basically document your API just like you would document a regular RPC API. You document the method names and the operations. And you hard code a lot of knowledge about the server details into the client, putting a huge burden on the client having to construct these URIs, and at the same time removing a lot of flexibility from the server in defining how these URIs look like, what they point to, and so on. And that can ultimately reduce the scalability of your server, because you can't just replace the server component of the URI and point to a different server when you want to scale out your service. That's impossible, because the clients are hard-coded to go to a singular server. Don't do that. To exemplify this, say you have a refer table and you create a lot of clients for this. You have integrators using the refer table. They have deployed thousands of clients using this table and selecting from it several times a second. And then you discover that, oh damn, there's a spelling error in the table name. That's the same problem you have when you hard code the URIs in the client. Now what are you going to do? You have to update all clients, or you have to create a new table and map between them, and you have a maintenance mess on your hands. If you had used Hypermedia, you wouldn't have that problem. And it's the same way with URIs. If these URIs are hard-coded in a client and you want to change the customer order URI, you now have to update the client. The same if you want to do a backwards incompatible change in the customer note resource. You now have to version all other resources with it, because they probably have something to do with each other. And now you have to update all clients to support that as well. And it's a mess. At Adobe Evolve conference in 2013, Roy Fielding proposed this question. what is the best practices for versioning REST APIs? And his answer, don't. And we'll get back to why and how you can avoid it. So now that we've talked a bit about what REST is not, let's try to talk a bit about what it perhaps is instead. To explain REST, I want to become a bit philosophical. Learning REST is kind of like learning a new language. A study called the foreign language effect, thinking in foreign tongue reduces decision biases, proves that when you talk and think in another language, you think and feel and behave differently. And I believe the same thing applies to architectural principles, programming languages, and pretty much any other abstract concept. When you truly learn the new concept and dive deep into it and understand it, you will think about the problem space in a different perspective. And that's why I believe that you can't use your current knowledge about RPC and procedural programming and object models and object-oriented programming and apply that to REST, because they are not the same thing. You have to readjust your knowledge and apply it differently. Now REST has a few constraints. I'm not going to go through them in detail because they are documented well on the web. But I'm going to focus a bit about the fourth sub-point of the uniform interface constraint. It says that Hypermedia should be used as the engine of application state. And that's a very hard question with an even worse abbreviation. And that's why I'm going to use some time explaining what it is. It says something about state. And to explain state, I'm going to use this example of a quote Roy Fielding had in an interview with Mike Amundsen, just how important the Hypermedia as an engine of application state is. It's not an option and not an ideal. It's a constraint. It's either you're doing Hypermedia as an engine of application state or you're not doing REST. So what is Hypermedia then? It's basically just links and operations. And those links and operations are analogous to real-life affordances, as popularized by Don Norman in his book, The Design of Everyday Things. Like a cup wants to be held and lifted, and like a button wants to be pushed, a resource should, through Hypermedia, explain to you or to a machine what it wants you to do. Don Norman defines affordances by, do people know what to do based on what they see? And in the same way we can define Hypermedia by, do machines know what to do based on what they see? Another way to view Hypermedia versus RPC is by the example of a map. RPC-style APIs work as a map. You get the whole landscape sketched out and hard-coded on a piece of paper. But what happens if there's road work, or if there's a new road, or if the map somehow is outdated? The infrastructure suddenly looks different than what the piece of paper tells you. Then stuff breaks, right? Hypermedia is more like the signs you discover while navigating through a city. It allows for unforeseen events, roadwork, and stuff like that. You don't have a clear view of exactly which path to take. You perhaps have an end goal. This is what I want to achieve. But how you get there is guided by the signs you see on the way. So, how does hypermedia look like in practice then? Like this. This is hypermedia. And most people probably know this as HTML. And if you do that, you already know hypermedia. So how can you transport your current knowledge of hypermedia in HTML to an API? Let's try to reformat these hypermedia examples a bit. If you just remove some attributes and make it more consistent, and then replace it with JSON, and then move stuff a bit around, we suddenly have a JSON document that might look like something returned from an API. Semantically, this is exactly the same as what we have in HTML, but now it's something we can use in an API. And as I've mentioned, we should use hypermedia as the engine of application state. So since we have state, the best way to explain it is through a state machine. And this is a state machine. It's a pretty simple one. It's a toaster. And it has a few states, so let's go through them. It starts in an off state. We turn it on, and it reaches the state on. We adjust the strength of how well toasted we want our bread, and it reaches the heating state. Eventually it reaches an upper temperature limit and goes into an idle state, cooling down. When it reaches a lower temperature limit, it goes back into heating state. And eventually our bread is toasted according to the strength we've configured, and the toaster is shutting down and eventually reaches the off state again. So by the example of this state machine, let's try to apply some hypermedia. Let's get the toaster resource. Okay, cool. We have a JSON document telling us that the state is currently off, and we have one operation there defined. If we take a look at that operation, it has a relation called on. Now that probably means that if we apply that operation to the resource, the end state of the toaster will be on when the request is completed. So if we break that operation down a bit and reformat it, it suddenly looks like an HTTP request. So let's try to apply that HTTP request. Yay! Our toaster is on. And we now see that we have two operations. We can turn it off, or we can adjust its strength. So let's try to apply the strength operation. And now you see the URI is just gibberish, because to us the URI don't matter. We discovered it in the response, so whether it's a GUID or whatever doesn't really matter. Now the strength operation has been applied and the toaster is heating. We have still two operations we can perform, but let's look at the ID up there. It looks like a resource, right? It's actually the same resource we initially did a get on. So let's try to do that again. Since our last request, the toaster has heated up and is now in the idle state. If we repeat the request, it has now been done toasting our bread and is currently shutting down. And as we see in the shutting down state, we have no operations we can perform on the resource. And lastly, the toaster is turned off. And we have back our on operation that we can perform to toast new bread. And to expand on these operations and link relations we find in our document, this is how you can apply and implement versioning. You just add links and operations to your resources, guiding new clients to new places and new states, while allowing old clients to follow the old relations and old operations, and you won't break anything. You will also have a minimum change to maintain in your API, because you don't need to create an entire new resource for every new version you want to support. And lastly, I would like to encourage all of you to join the Slack HTTPIs channel. It's a very good community to discuss API development. I'm there, Mike Amundsen is there, Sebastian Lambla is there, and many other great API people. So please join. Thank you.